Hello everyone, thank you for joining me for this video. You have found this video either because it was linked for you in the description of the YouTube videos related to steel construction, or because this was linked for you on Brightspace as it relates to your assignment number 1. The idea behind assignment number 1 is that it's meant to give you an opportunity to practice what happens quite often in our business, I should say mostly in yours, and that is that you might have to detail the structural connection by hand of elements on site, say, by a hand sketch, so that then you can present that hand sketch to someone else, whether it's someone else in your company or yourselves, so that you can then reproduce it into professional drawings in CAD or a similar package. The idea then is that with this assignment, you're going to get to practice drawing various structural elements, their connections, their assembly by hand to get a feel for how they connect together. Okay? It's not the same thing when you do it on CAD. There's a benefit to doing it by hand. And then you get to practice putting them together to see how they fit together and the relative scale of various elements. I recommend before you get started that you make sure that you download the Ask sheets or sheet, if there is only one, from Brightspace. That's the one that you're expected. You want to make sure that all of your drawings are labeled properly according to the Ask sheet, because any orphan drawing is a 0 drawing. Okay? You also want to make sure that the line weights are correct, right? The same line weights that you learned how to do when it comes to hand sketching in all of your previous courses. You want to make sure that if an item is close to you, or if it's the edge of that item and has that thicker line, right? Labeling, we'll see it as we get through this. You want to make sure that it's done properly, right? So there's a text, which is typically horizontal in orthogonal drawings, and then there's a horizontal line that comes out of that text for your label, and then an oblique line, usually at 45 degrees, that points with a very pointy arrow to the item you're looking to point at, not through it. You want to make sure that any item that is behind something else, if it needs to be shown, is shown with a dashed line, that kind of stuff. Okay, so without further ado, maybe let's get started. Here you'll see this here is drawing S1. Okay, and that's how I'd like you to label this in all future drawings according to the drawings that I'm showing to you on the screen. Drawing S1 will be the one that's going to show all the primary components as an isometric drawing. So you'll notice that, for example, here it's showing a column with the size, column here with the size, a W section with the size, and so on and so forth. And by now, because you've viewed the video lectures for steel construction, you know what those letters and numbers and a multiplication sign means. Now I'm showing you here certain sizes. For example, for this W section, I'm showing a W410 by 39. For your assignment, these 4 elements might be different sizes, so check on Brightspace to make sure they're different or the same, because it will affect the actual geometry then of these various shapes and sizes. And don't forget to check under resources where you can go online to find those dimensions, because if these are different, then that means that all of these dimensions too are also going to be different. Okay, so you want to make sure that they're done properly. Okay, so the first drawing that you're going to do is going to be of the 4 elements as they relate to the drawing. Okay, pardon me, I'm just going to delete these and move on. So that's going to be S1. So all the relevant dimensions for the specific 4 shapes that are in your assignment number 1, they're likely going to be different from what you see here. Drawing S2 is the typical pier number 1. Okay, S2. And what you're showing with this is a plan view, a top view of a concrete pier, and then at the bottom of a steel column fastened to it, where you see a plate here, and then in this case the W section. Okay, so sorry, let me just delete this, like that. Okay, and then there's the W section right here. Right there, okay? And the idea is that you want to show the dimensions from the edge of the pier to the middle line. That's where the grid lines will pass. In this case, it shows as 700, okay, right here. And then you also want to show the various items that are shown here as well. So that includes the naming of the pier. In this case, it's Pier 2. Okay. So in this case, it's Pier 2. You want to show that there are 4 bolts. In this case, they're 19 millimeter diameter and they're 500 millimeters long anchor bolts, which we'll see in another drawing that's coming up shortly. You want to show the dimensions of the base plate. Okay, so in this case, it's 300 by 300 by 19 millimeters plate. So that's 300 by 300 by 19 millimeters thick. And then here, you want to show the correct column size, right? This is appropriate for the drawings I'm showing you, but not maybe for the assignment 1 that you're being asked to do. And then the various items here too, as well as the dimensions from the center of the bolt hole to the center line and from the edge of plate to the center line. Great. Now for drawing S3, it's another pier. This is the pier that's going to be under the HSS columns. So you're going to show again the dimensions of the pier from edge of pier to center line, from edge of pier to center line, the type of pier, because maybe you have multiple shapes of piers or dimensions of piers, your anchor bolts, how many there are, what their diameter are, and what their length are, the size of the plate. Use this dimension for plates under HSSs. So it's 500 by 500 by 19 millimeters thick. The HSS that you're using, again, it might be different from this one, so check on Brightspace. And then nut and washer, shop weld. The shop weld is the one that goes all around your shape. And then again, the same dimensions that go from the middle of the bolt hole to the center line and from the edge of plate to the center line. Okay. So then we're just going to move on to this. Now this is a side view, right? An elevation view of the same connections we just saw in S2 and S3. This one here refers to S2, right? It's the connection between the W shape right here and the pier 2. So you want to show again the same anchor bolts that you have, right, from S2, that there is a nut and washer, the base plate, and then you'll notice that under the base plate there's also a 6 millimeter leveling plate. This is a steel plate that's put under that base plate to level it out as a level surface between that base plate right here and the non-shrink grout right under it. That's what this is showing. Okay, that's 25 millimeters minimum. That's what note is saying. High strength, non-shrink grout. And then you'll also notice that sometimes you can even put leveling shims between the that leveling plate, right? Because it helps you level the bottom of the column. All right, so then F5 is going to be exactly the same, but for the connection between the HSS column and the pier under it. So everything is exactly like S5, except that certain dimensions or sizes are different, or the labeling is different, right? You have to show that this is an HSS column, whatever the dimensions of the bolts are from S3, as well as the non-shrink grout and all the same other items that we've shown previously on S5. Now, for S6, drawing S6, we're moving on to isometric drawings, okay? Which I'm expecting you to reproduce as well. And what this isometric drawing is the first beam to column connection. In this case, it's a connection between the W column and the W beam. So be careful with the labeling. It might be different depending on the sizes of beams and columns that you've been asked to reproduce for assignment 1, right? So these may be the same or may be different. These may be the same or may be different, okay? You'll notice now that this connection is a shear connection. And if you don't know what I mean by that, go view the lectures for steel construction. But it's a shear connection between this beam and this column, because only the web of the column is connected, of the beam is connected to the column. In this case, it looks like we have an L-shaped plate, an angle, that is welded to the beam all around and then bolted, as you can see here, to the column. Okay, so you want to reproduce then all of the elements you see here, including these dimensions, right? These notes. And you also want to properly reproduce these relative dimensions. So you see here, according to this drawing, when they looked up the dimensions of whatever this column was and whatever this beam was, they found that the width of this flange was actually wider than the width of this flange. So you need to make sure that that's true for whatever combination of beam and columns you get for your assignment 1. Okay? That's why you do that first S1 drawing. Okay? All right, S2, it's another shear connection. You've seen this in the lecture videos. It's a seated connection. It's a seated connection because you have this seat right here, this angle that is welded to the column, this column right here. And then you're bolting the bottom flange right here to this seat, right? That's what you see here. So you want to show it as it's shown here as an isometric drawing. Make sure this here represents this here, and make sure that this here is the proper labeling for this column here. The one that's shown on this drawing might be different for the one for your assignment 1. So make sure that's true as well. You want to make sure that there is a note that says field weld top stabilizer angle with an L100 by 100 by 13, and as well as this note you see right here. Okay? Then S8 is another connection, but this time it's a beam to column connection that is a moment connection. It's a rigid connection. Okay? And it's rigid because both the web and the flange of the beams are fastened to the column. So let's look at this one first. We have a beam, in this case, whatever it is in your assignment, that is completely welded along the top flange, the web, and the bottom flange to this column, whatever this column size is depending on your assignment. And then you'll notice that there's also a shop weld that fastens this L seat right here. Okay, so this shop weld fastens this L90 by 90 by 6 to the beam and the column, to the column, so that the beam can sit on it, right? It makes it easier to put it on site. This connection here is slightly different, right? You've seen this in the lecture video for construction, for steel construction. And basically what we have is a very rigid connection where there's a top plate, web plate, and a bottom plate that are welded to the column but bolted to the beam, as you see here. Okay, so you want to label it properly as it shows here with the specific labeling. So a 19mm plate shear tab. You want to indicate what this beam is, but the correct dimension for your assignment 1. And you want to correctly label this top flange plate, which shows as a 25mm plate. And as I'm mentioning this, I also want to point out this. You want to make sure that the relative dimensions, the relative scales of your elements are about right. So I'm not saying that this needs to be to exact scale everything, but it needs to be relatively correct. So what I'm getting at is, for example, you see this plate here, it's being labeled as being 25mm. So this relative thickness should match, if it's the same as that thickness, say, it should match in terms of relative size to the eye, okay? Ditto for this. You see how the top of this flange seems to be wider than this flange here for this column? And that's because for this sketch, maybe it was wider, okay? So you have to be careful about that kind of stuff because the relative the relative scale needs to be correct. Now moving on to S9. This is an example here, actually. It's very interesting because it's two W sections that are fastened into an HSS column. So you want to properly label whichever this HSS column is for your assignment number 1. And the way it's set up is that first, the plates, these plates are welded to the HSS column, okay? And you usually will include seats, like you see here, to locate those plates properly. And it also helps to place a beam in place. Then you're going to weld the beams to the plates. And this is a very good example of those instances where welds are superior to bolted connections. You see, you could not do this connection, that is, fasten a beam to a column, if the column in this case is an HSS. Because the only way to do it, right, to bolt something, you have to drill a hole and then put a nut on one end and the other to fasten your bolt. But you can't do this with this, because if you make a hole here to fasten this and you put the bolt through here, the only way that you can fasten that bolt is if you put a hand down this column and reach all the way down to then fasten that, to tighten that bolt nut. But that's usually impossible to do in construction because your arm is only so long, right? And it might not reach wherever that bolt is. Also, in construction, these columns may not be open for you to reach in. They might be capped with a plate. So this is an example of where welds are superior. So you want to make sure that you add all of these notes in place, right? And make sure that the elements and the sizes that you're using for this shape match the ones of your assignment number 1. This is an example of a moment connection between beams and columns, S9. S10, this is showing here. Let me just remove this. Okay, this is showing right here an example of a K-brace, okay, over 2 stories. You can see it here, okay? And this is so-called K-brace because of this shape here, okay? Here, here, and here, right? Because it basically kind of looks like a K, a capital letter K. Make sense? Okay. So what you're showing with this is a general layout of a K-brace, and you want to show this as it is, okay? And it's basically showing the setup of a K-brace so that then you can show the details of the connection to right here. Oops, let me just point this out here so that you can show the details of the connection between the column, the brace, and the pier, and the details of the connection between the braces, right? So that's these elements here, the braces and the beam, okay? So how it looks right here. So we're going to show that in the next drawing, S11. So that's the connection between the column right here and the braces right here, okay? And the way that it's set up is you have this column that is fastened to the pier, as we saw in drawings S2 or S3, depending on whatever that column might be, okay? The way it's set up is that these plates right here are shop welded to the column, okay? They're shop welded to the column, and then you bolt the braces right here. You bolt them to these plates, but as a sandwich. So basically these braces you see right here, okay? There we go. Oh, let me try this again, sorry. Oh yeah, let me just get rid of this. Okay, so what you see, these braces right here. My tablet is misbehaving. Sorry, just give me a second, okay? So these braces right here, okay? All right, I'm gonna use my mouse. So these braces right here, these C channels, the way that they're set up is they're back-to-back C channels like this, okay? They're back-to-back, but at the location of the plate, there is this plate between them that looks like this, and you're bolting them through like that, okay? That's how it's set up. So then you want to show the gusset plate right here, and all the other dimensions that are shown here. You can just repeat these dimensions, okay? All right, so that's S11. For S12, that's the connection between the braces and the beam. So you want to make sure you use the proper beam to match your assignment, okay? So if it's not the same one as your assignment, you want to make sure that you match the one in your assignment number 1, which might be the same as this, or it might not be, okay? I'm not sure what's happening with this tablet, so we'll forget about that. Okay, so the dimensions that you want to use are the same that I show here. Okay, you would use different ones if you were to actually size them, but just for ease of reference, because this is just an exercise, you'll use all the dimensions that I show here. Okay, including the size of the gusset plates you're going to be using, the number and type of bolts, the same diameter bolt, and the same spacing of bolts. So ditto also for these gusset plates here, right? You want to show all of that as being the same. The one thing that I want to point out to you is these items right here. These two, okay, these are plates and they're labeled right here, okay? But you want to make sure that you're actually pointing to them, because this one is not properly pointing to it. You want to make sure that you're pointing to the plates. Those are web stiffeners. As it shows here, they're a 25mm thick plate web stiffener, okay? And what that web stiffener is doing there is basically trying to prevent this beam, let me just clean this up a little bit, is basically to prevent this beam from being crushed at these locations here. So you're basically reinforcing the beam right here by placing those web stiffeners. That's their purpose, okay? That's S12. Okay, S13 is a connection between a steel beam and a hollow core slab, okay, with the shear studs right here. This is not mandatory. You don't have to do S13. It's not required, but it might be helpful to you for further examples, details, assignments, okay? And the last one is S14, which you find right here, which is the connection between an open web steel joist, the deck, and a beam. So we have a beam here. Make sure that it matches the size of whatever beam you have for your assignment 1. And then you can use these dimensions here for the steel deck, right? The steel deck is sitting on top of this open web steel joist right here, okay? Notice how there is a shoe coming into place. This is 65 by 65 by 10, and it's 100mm long. The dimensions of your steel deck are showing right here, okay? Again, this is shown for you in the lecture for steel construction. So if this doesn't look familiar, go check it out there. And you want to just maintain these dimensions just for the sake of exercise, including also these notes and pointing to them, okay? And that's it. These are the drawings that I require you to put in place. Okay, so that should come out to be, I believe, 12 drawings. 12 or 13 drawings, okay? Because S13 right here is not required, okay? You won't be graded on this. So that's it. This is the last drawing. Make sure that when you submit these drawings as a single PDF document, all drawings, hand sketches, are clear, professional, the right side up in the right order, labeled, identified, okay? It needs to be a professional submission, and that's because Brightspace only keeps the last document. So if you upload them one file at a time, Brightspace will only receive the last drawing you upload. Put them all into one, make sure they're the right side up, all in portrait, make sure they're clear and not out of focus, make sure they're properly labeled and not orphan drawing, because an orphan drawing is a 0. A non-professional drawing is a 0. A drawing that's out of focus is a 0. Now, I know you recognize this, but that's just to prevent the possibility that some of you might not realize that, right? The professional submission needs to be good, needs to be up to the standards that you expect and that the people in our business expect, okay? That's it. I think I'm talking too much. I'm going to let you go now. Thank you so much for your time. And the link at the bottom in the description of this YouTube video will also point out to the main lecture if you want to get started with that again for steel construction. Thank you so much and have a lovely day.